Hey Science 8 class, today I'm going to show you a little experiment about density and how it relates to our Earth's layers. What is density? It is the measure of how much mass there is in a given volume. So, if the mass of something increases but the volume stays the same, then you could say the density has increased. So, think about it this way. If you dissolve sugar into water, the amount of water does not increase, but the density of water does because the sugar is taking up more space between the water molecules. So, I have a glass of water here, and if I add the sugar in and I mix it up, sugar is water soluble, so it will dissolve in the water, but the volume of water in the actual glass won't increase. Another way of thinking about density is asking the question, why does ice float on top of water? So, like most things that float, ice floats because it is less dense than liquid water. Ice is about 9% less dense than water, so when ice forms, it takes about 9% more space than it did as a liquid. So when you drop some ice in a glass of water, it floats on top because it is 9% less dense. That's just a quick little introduction about density. So now that you have a better idea around how density works, it's time to do our experiment. Alright, now that you have a better understanding on what density is, we're going to do an experiment called the density jar to represent our Earth's layers. So in front of me here, I have three household liquids. So the first is maple syrup, original flavor. Maple syrup has a density of 1.32 grams per milliliter. So we're going to use maple syrup today to represent the density, the layers of the Earth called the inner and outer core. So usually I would separate them, but today we're just gonna make maple syrup represent both layers. So you take your maple syrup if you want to do this at home, and then you're just gonna pour it into a see-through glass or jar. That's a lot of maple syrup. Awesome. So the next layer, if we go in sequential order, is the mantle. So today we're gonna use Powerade to represent water, and it's going to represent the mantle. So you're going to slowly pour in your water, and you'll notice that the water, which has a density of 1 gram per milliliter, is less dense than our maple syrup, so you get a very distinct layer. We'll just sit on top of each other. And finally, we're going to use some canola oil, which has the least density. It's going to represent our crust, so the layer on which we live on, stand on, and the tectonic plates are located. All canola oil has a density of 0.92 grams per milliliter, so a bit less than water. So if you pour it in, once again, you'll see it floats at the top. So that signifies to you that it is less dense. So just a little close up here, you have three distinct layers which represent the Earth's layers. So at the bottom we have the inner and outer core, the mantle, and on top we have the crust. Just to go a little bit further with this experiment, we're going to drop in some solid items just to show you a bit further how density works. So here I have a screw. It will have the highest density, so when I drop it in, it sinks to the bottom. Just a close up on that one. Screws at the bottom. So the screw has a higher density than the maple syrup, so it is at the bottom. The next item we have is a strawberry. I'm gonna drop it in and see where it lands. As you can see, the strawberry is actually floating on top of our water. So that means that the strawberry has a slightly less density than the water. So it floats on top of the water and it doesn't sink to the bottom like the screw. And finally, we here have a cap from the canola oil. And when I drop it on top, it floats. So that means that the cap has less density than the canola oil, which is 0.92. And yeah, that kind of represents density through our experiment. Just one thing I'm going to quickly touch on that we'll go over in later in the unit and in a different class is it's just another way that we can think about density and the layers of our Earth is to think about the atmosphere. So the atmosphere is a almost invisible layer above our heads. It is the least dense layer of our Earth, and that is why it is on the outside, so above us and above the crust. And the crust is the second least dense layer, which is beneath our feet. So because we as humans are less dense than the dirt or the crust, we do not sink to the ground. And even though there is about 1 ton of atmosphere above our heads right now, it is not dense enough to send us floating up. So if we were less dense in the atmosphere, we'd actually start floating up into the air. So I hope you enjoyed the brief introduction to density, and it's your turn to try this experiment at home.